In this session, we are discussing about the analog modulation schemes. Okay, so it's a basic concept. Analog modulation and digital modulation are two streams in communication system. And analog modulation systems are very important because 3 or 4 questions are asked on an average in every paper, list papers. And it is a basic a topic also as far as communication system is concerned. So we'll start this analog modulation schemes. Okay. Hope you know basic terminologies. Anyway, you can ask any doubt. So first of all, what is communication system? A communication process. So it involves a transmitting station or transmitter and a medium through which information is transmitted, and finally a receiving side or receiver. The communication system is a process of establishing this connection or link between 2 points of information exchange. One is called a transmitter. If a radio communication is concerned, there will be a transmitter, transmitting station. Radio station will be a transmitter, and receivers will be household radios. Okay, so in a communication system, we can draw a basic block diagram that consists of 3 blocks. First one is transmitter. So this transmitter transmit information, and information is transmitted through a channel. Okay, now this represents a channel. There are different forms of channel. And at the receiving side, at the other end, we have a receiver. Okay, receiver. So this is transmitter. And link is called medium. Okay, this is communication channel. You can put down few important points that are discussing. Okay, you can note it down. Communication channel. In the transmitter side, information. There are different forms of information. It may be audio information. In the case of radio communication, audio is the information. It may be picture information. Picture information, multimedia services, or text can be sent through fax. Okay, so audio, picture information, multimedia information, or can be taken as information signals. And in the transmitter side, there will be a processing system which converts this information into a convenient form so that it can be transmitted through the communication channel. Okay, if you consider channel, there are different forms of channel. It may be a coaxial cable or a pair of lines or optical fiber. Even air can be treated as a communication channel. Okay, radio communication or mobile communication at the receiver side is taking place through the atmosphere. Okay, so communication channel, and at the receiver side, we have a system. Which demodulates or decodes. Information is decoded here. Decoded means that is its initial form or true form of the audio, picture, or multimedia information will be decoded or demodulated in the receiver side. Okay, hope you understand basic structure of communication system. Okay, it consists of a transmitter which transmits information, and there will be some processing technique that converts the actual information into a transmittable form, and it is transmitted through the communication channel. At the receiver side, the opposite process is done. Now, based on the information that are transmitted through the communication systems are classified into 2 general terms or two general systems. They are analog system, in which analog information is transmitted through analog modulation schemes. Here, modulation is done in analog domain. So modulation process is done is analog. Information will be analog. Basically, information will be analog because if you consider audio signal or speech signal, it is analog in nature. But it is converted into digital form first. Then this digital information is transmitted, okay, using digital modulation schemes. In digital communication system, informations, even analog informations, are transmitted in digital form. Okay, digital modulation schemes are employed. Digital modulation schemes are employed in the system. Okay, I hope you understand. Okay, right. Let us move on to next topic. Yes, thank you. Analog communication. As we discussed earlier, analog communication system use modulation systems or techniques that are analog in nature. What is meant by analog? Analog means continuously varying information. Or if we consider signal which is continuously varying with the time, such signals are called analog signals. Okay, so continuously varying signals are called analog signals. So in analog system, we will change one of the characteristics. This is important. One of the characteristics of the carrier is changed. Okay. Now, what is meant by carrier? Carrier is a signal which is used to transmit, which assist the transmission of modulating signal or information signal. Okay. So we have a carrier to transmit a modulating signal. So modulating signal will be the modulating signal. The signal is information bearing signal, information signal. Okay. Information is in modulating signal. And we are using a carrier. This will be a high frequency signal. Carrier is usually a single frequency signal. Carrier can be written as a sinusoidal signal. Okay. So amplitude of carrier be AC, then it may be written as sine or cos, cos 2 pi fct, like this, plus phi. This represents a carrier signal, which is a truly sinusoidal signal. Modulating signal may be instantly varying signal, the amplitude, frequency, phase of which cannot be predicted in advance because it depends on information that are coming from the source. So this is transmitter side, and in the transmitter, there will be some modulation process in which carrier amplitude, frequency, or phase. Now AC represents amplitude. What is the amplitude of a sinusoidal signal? It is the peak value. Peak value achieved by a sinusoidal signal is called amplitude. Okay. Amplitude, what is amplitude? It is a peak value, and AC is the peak value of the carrier. Okay. Now it is fixed value. Amplitude is fixed value as far as this carrier is concerned. Okay. So peak value is fixed. Now we can vary the peak value or amplitude of the carrier in accordance with the instantaneous value of the modulating signal. Okay. So here we are changing the amplitude, peak value, or amplitude of the carrier in accordance with the information signal. And this is an analog modulation scheme called amplitude modulation. So based on the feature or characteristics of the carrier, which is varied, we have AM, that is amplitude modulation. Second one is, second characteristics of carrier wave is frequency. See, FC is frequency of the carrier wave, which is also fixed as far as carrier is concerned, but we can vary the frequency of the carrier in accordance with the instantaneous value of the modulating signal. Here, we are varying frequency of the carrier in proportion with the modulating signal amplitude. Okay, right? Okay. So in that case, we are generating frequency modulated signals. Okay. Frequency modulation is the process. So frequency modulation. Okay. Modulation. Just can note it down. Modulation, frequency modulation, simply called FM. In FM, the frequency of the carrier is varied in proportion with the instantaneous value of the modulating signal or information bearing signal. And the output of the transmitter is called modulated signal. Modulated signal. Clear? So there are three signals, two input signals. Input signals are modulating signal or information signal. Second one, carrier. Carrier is a sinusoidal signal whose characteristics can be varied in proportion with the modulating signal to generate different modulation schemes. So third one is phase. This is phase. I'll use another ink. Phase. The phase of the carrier is varied in proportion with the instantaneous amplitude or instantaneous value of the modulating signal. Then we'll get the which modulation? Third modulation. It is phase modulation, right? It is phase modulation. Phase modulation. Or in short form, it is called PM. Okay. So these are basic analog modulation schemes. In analog communication, we are using these modulation schemes to modulate a high frequency carrier in accordance with the instantaneous amplitude of the modulating signal. Okay. I hope basic concept is clear. So you all understood what is meant by amplitude modulation, frequency, basic idea of AM, FM, and PM. We'll go into details, all of these amplitude modulation, frequency modulation, and the phase modulation. Today, session we'll discuss amplitude modulation in detail, right? Okay. First, advantage of analog communication. What are different advantages of analog communication as compared to digital communication? So we have two different systems, analog and digital communication system. Advantages of analog communication are transmitters and receivers are simple. Okay. We are using analog communication because of this receiver simplicity. Radio receiver is very simple. Analog receivers are very simple. So transmitters and receivers are simple. Constructionally, they are simple. Thing is low bandwidth requirement for analog communication. Analog modulation schemes are relatively low compared with the digital modulation schemes. So these are 2 points. First 2 points. Third one is FDM. So what is FDM? Sometimes this expression of this term. FDM means frequency division multiplexing. FDM, frequency division multiplexing. Multiplexing. So multiplexing is a technique by which different signals, information signals or modulated signals can be transmitted through the same medium. So different informations means information coming from different sources can be combined. They are combined and transmitted through the communication media without the mixing of these signals. Okay. Okay. FDM is a technique in which the total frequency range, if we consider the frequency along this axis, total frequency range. So if we are considering it is say 5 megahertz to say 50 megahertz as an example. This is the frequency range, total frequency range from 5 megahertz to 50 megahertz. We can transmit 9 different communication signal channels through this frequency range. Okay, we can transmit 9 different radio stations or communication signals through the entire frequency range by dividing this into frequency slots. If one station is using or one transmitter is using 5 megahertz frequency range, if this is the bandwidth of single user, then we can allot 9 different users in this frequency range. One is from 5 to 10. This is from 5 to 10. One user 1 is allotted this frequency range. Second frequency range is allotted for second user, next user, that is from 10 to 15, and so on. So we can allot 9th user here. Okay, then total frequency range. In this case, total frequency range is divided into different frequency slots, each having 5 megahertz frequency band. Okay, so in FDM, which is used in radio communication, because in radio communication, the medium of communication or channel is atmosphere, and different radio stations are allotted different frequency ranges, so that their signal will not be mixed up. Information will not be lost when they are transmitted through the same medium. So this will be possible only if we are using some modulation technique. FDM is a multiplexing technique where total frequency of the channel is divided among different users. So it is clear. Next, disadvantage of analog communication. What are disadvantages? So there are several disadvantages. First one is noise affects signal quality. Noise effect is more in analog communication. If you consider AM, FM, or PM, when compared with the digital communication system, noise effect is more in this communication system. That is point number 1 as far as disadvantage of analog communication is concerned. Second one, it is not possible to separate noise and signal. Noise separation is difficult in analog communication. Okay, in digital communication, it is very easy to separate noise and signal by using restoration of pulses. Pulses can be restored using regenerative repeaters. So repeaters cannot be used in between transmitter and receiver. Repeaters can be used in digital transmission, but repeaters can be used in analog communication system. Next one, coding is not possible. Coding is used to detect and correction of error or noise. The error or noise effect can be detected by using suitable coding technique in digital communication system, which is not possible in analog communication. So this is a disadvantage. Last point, it is not suitable for transmission of secret information. In this case, there is no encryption scheme. Encryption scheme means information can be encrypted and can be securely transmitted through the communication channel. Digital communication system, we are using this encryption and encoding technique so that information will be secured. So it is not suitable for transmission. This analog communication is not suitable for transmission of secret information. Okay. So note these points, advantages and disadvantages of analog communication. Hope all of you understood. Let us move on to next slide. Need for modulation. Why we need modulation? If message signals are transmitted without modulation, what is the problem? Why we are using this complex system of modulation before transmission? So the answer is few points are usually analog information is baseband information. What is my baseband? Baseband baseband information is low frequency information. We know that voice signal, audible voice is from 20 hertz to 20 kilohertz. Okay, 20 to 20 kilohertz is the audible frequency range. If you are using a transmitter of this frequency, then the antenna height will be very large. Okay, as frequency decreases, wavelength increases. Therefore, the antenna size, antenna height required will be in the order of kilometers, few hundred kilometers. Okay, so for transmitting very low frequency signal, which is baseband signal, we need a very high antenna. So antenna height can be reduced if we transmit this audio frequency using, say, 200 megahertz carrier. This is carrier. Okay, if you are using a carrier, now the frequency range of 20 to 20 kilohertz is converted into 200 megahertz range. Okay, so that it can be transmitted very easily. And antenna height will be of the order of few meters. Okay, this is the first point. So for ease of transmission, we require modulation schemes. Okay, so modulation is a process of converting low frequency baseband information into a high frequency radio frequency information. Radio frequency range, it is converted into radio frequency range. Next, long distance communication. Okay, long distance communication, telecommunication is possible only due to modulation. Okay, so that we can use properties of atmosphere, sky, properties of sky, so that long distance propagation can be can be done. Ease of radiation. Okay, mid frequency range can be radiated very easily. RF frequency can be radiated very easily. Okay, the system for transmitting RF signal is less complex than low frequency signal. If you consider filters, amplifiers, tuned amplifiers, etc., so they will work fairly well in RF frequency range. Okay, next point is multiplexing. We can multiplex, use FDM technique or TDM technique. FDM, we have already discussed about FDM. This technique will be possible only if we modulate signal. Okay, otherwise all the radio stations, if you consider radio stations, they are transmitting information in audio frequency range. Audio frequency range is from 20 to 20 kilohertz. So if all radio stations are transmitting information over the same range, these signals will be mixed up in the channel and information will be lost. So that is not taking place in radio communication, because there we are allotting different carrier frequencies to radio stations, so that their frequency will be separate in the band. So multiplexing technique can be employed only if we use modulation technique. Third one, we can use filtering technique and improvement of signal to noise ratio by designing systems if we employ modulation scheme. Then avoid mixing up of other signals. Okay, that we have already discussed in multiplexing technique. So this will avoid mixing up of other signals. We are using different frequency range for different users, and mixing up can be limited in the case of modulation systems. So these are need for modulation. Okay, hope you understood. So take it down, these points, reduction in antenna height, long distance communication, ease of radiation, multiplexing technique can be employed, improve of the quality of reception, avoid mixing up of other signals. Okay. Next, we'll discuss our main topic is amplitude modulation. Amplitude modulation is a process of changing the amplitude of carrier signal with respect to instantaneous change in message signal. In a communication system, modulating signal and message signal, modulating or message signal and the carrier is applied to the modulator. Carrier is applied to the modulator. Carrier amplitude is AC, cos 2 pi FCT is the frequency part. If you are applying this carrier and modulating signal to the AM modulator, this is block diagram of AM modulator, amplitude modulator, we'll get the AM out. In AM system, the amplitude of the carrier amplitude is varied in proportion with the modulating signal. So that is amplitude modulation. It is the process of changing the amplitude of the carrier with respect to or in proportion with the instantaneous value of the message signal. So we'll discuss in detail. Here you can see modulating signal, carrier wave, and modulated signal. First figure is modulating signal. This is information signal, modulating signal or information bearing signal. Message. It is an arbitrary signal. It is not a pure sinusoid. It is arbitrary signal. But carrier is a pure sinusoid, and the peak value of carrier is denoted as AC. Peak value of carrier is denoted as AC. You should note the notations. AC is used for denoting the carrier amplitude. Minus AC is the negative value. So carrier amplitude is varying within this limit, minus AC to plus AC. It is a sinusoidal waveform. And after modulation, we'll get a modulated signal. Blue color indicate modulated signal. And the amplitude variation, if you observe the amplitude variation of the modulated signal, you can see the amplitude variation is in proportion with the modulating signal. So this is AM signal. After modulation, the amplitude of the carrier wave, that is peak value of the carrier wave, is made in proportion with the instantaneous amplitude of the modulating signal. So after modulation, you can see a variation like this. Amplitude variation will be proportional. That is this dashed line, black line indicate the shape of actual modulating signal. Okay. So modulation is a superimposition of modulating signal and carrier. Okay. These two signals are superimposed to get a modulated signal. So what are mathematical representations of this signal? We'll deal few mathematics because numerical questions are also asked in this topic. Basically to calculate power of AM, bandwidth of AM, and also carrier power and sideband power. Okay, mostly related to modulation index, carrier power, and AM power. Now, first thing we are going to discuss is spectrum of amplitude modulated wave. Now, what is meant by spectrum? It is the frequency components present in an AM wave. The AM amplitude modulated signal, it is composed of modulating signal and carrier signal. After modulation process, it will contain different frequency components. Okay, AM modulated signal contains different frequency components. What are they? First frequency is carrier frequency itself. FC, carrier wave frequency. It contains carrier frequency component. Second frequency is called upper sideband frequency. Why is called upper sideband frequency? It is frequency above the carrier wave. Since upper sideband frequency is above the carrier wave, its frequency is FC plus FM. So the component which is having frequency FC plus FM is called the upper sideband, or in short form it is USB. Okay, USB, upper sideband. And third one is lower sideband. FC minus FM is lower sideband. In short form, it is written as LSB. Okay. And modulating frequency component is not present. It is not present in AM. Okay. So main thing you have to understand is AM is composed of 3 different frequency components. Okay. The first one is carrier frequency itself. And second one, upper sideband frequency USB, and third one, FC minus FM, that is lower sideband frequency, LSB. Okay, we will discuss more about this. First waveform, here all waveforms are given. First one is modulating signal. You can see this red waveform. And it is plotted as a function of time along this axis, time axis. You can see time axis here. Okay, modulating signal. Red curve is, or red waveform is modulating signal, and carrier amplitude is a fixed value. Carrier frequency, carrier. Where is carrier? Carrier is in this color, green color, green or blue. Yes, green color. Carrier frequency is given in blue color. This is carrier. Modulated signal, that is this one, AM wave. This will contain first component, lower sideband component. Second component is carrier frequency component, unmodulated carrier. And third component is upper sideband, lower sideband, carrier frequency, and upper sideband. You can see the difference in frequency. The period of these signals are different. Which component is having highest frequency? Highest frequency is for upper sideband. Okay, upper sideband frequency is FUSB equal to FC plus FM. And carrier frequency is FC, and LSB, FLSB is FC minus FM. Okay, all of you know these frequencies, FUSB, FC, and LSB. So AM composed of 3 frequency components: carrier frequency, upper sideband frequency, and lower sideband frequency. Frequencies of USB, carrier, and LSB are given here. So FM is not present. Modulating frequency is not present in AM. Okay. Right? I think you understood this figure. Frequency components in AM. Right? Okay. Spectrum can be conveniently drawn. Yes. Spectrum can be conveniently drawn like this. See, modulating signal, if you consider a modulating signal, which actually contains different frequencies. It is starting from frequency, starting from 0 to maximum frequency FM. If you consider sound wave, it contains frequency from 0 to 20 kilohertz. So that is spectrum of baseband signal. This is called a baseband spectrum. You can see baseband spectrum, which is given in this shape. It is arbitrary. We are taking a baseband, strictly baseband signal, band limited signal. For spectrum, frequency versus amplitude curve is called the spectrum. So spectrum consists of frequencies. If you denote frequencies in hertz, it is from minus FM to plus FM. Okay. So frequency range is 0 to FM. That means spectrum should be drawn from minus FM to plus FM. Spectrum contains negative frequency components also. It's a mathematical representation. Actual frequency range of the modulating signal is from 0 to FM. But when you draw spectrum, we'll use negative frequency concept also. So frequency range, spectral components contain from minus FM to plus FM range. If you consider an unmodulated carrier wave, this is carrier, okay, carrier wave, whose frequency is a fixed frequency Fc. In this case, spectrum consists of two impulse signals, two signals that are denoted in as an arrow mark, and this is called the line spectra. Line spectrum. If a signal consists of a single frequency, it will be a line spectrum. A single line indicates a single frequency. Corresponding linear frequencies, this is given in angular frequency. You can write linear frequency also. Linear frequency is minus Fc and plus Fc. Okay, linear frequency. This is in hertz and omega c is taken in radian per second. Now, after modulation, the modulated signal consists of carrier wave. This is carrier. This arrow mark indicate, or this impulse function indicate carrier component in the modulated signal, and the frequency range above the carrier frequency is called upper sideband ESB. Upper sideband is the frequency above the carrier frequency. It extends from Fc to, what is the maximum value here? Fc plus Fm. So upper sideband extends from Fc to Fc plus Fm. And we have a lower sideband also. Lower sideband extends from Fc minus Fm to Fc. So the frequency range of lower sideband is from Fc minus Fm to Fc, and frequency range of upper sideband is from Fc to Fc plus Fm. Okay. So two portions are upper and lower sideband. Okay. You can mark these two portions in different ink so that you can understand the difference between these two frequency ranges. Upper sideband and lower sideband. So the overall frequency components in AM signal is from Fc minus Fm to Fc plus Fm. The frequency range of AM is from Fc minus Fm to Fc plus Fm. Using this, we can calculate bandwidth. What is bandwidth? Bandwidth is the difference in frequency between highest and lowest frequencies. Difference between the highest and lowest frequencies of the signal. If we consider modulated signal, the frequency range is from Fc minus Fm to Fc plus Fm. The frequency range of modulated AM signal is from Fc minus Fm to Fc plus Fm. So which is lowest frequency out of this? Lowest frequency is Fc minus Fm, and highest frequency is Fc plus Fm. So upper sideband frequency is the highest frequency, which is Fc plus F. Lowest frequency is lower sideband frequency, Fc minus Fm, and highest frequency is FC plus FM, that is in upper sideband. So bandwidth is the difference between F max and F minimum. So if you take a difference between FC plus FM and FC minus FM, you'll get the bandwidth of AM as 2FM. And that is equal to twice the frequency of the modulating signal. So bandwidth of AM signal equal to twice the bandwidth of the modulating signal, twice the maximum frequency of the modulating signal. You can write like that, twice the maximum frequency of the modulating signal, or you can write it as twice the bandwidth of the modulating signal. Okay, the bandwidth of AM is an important equation. Bandwidth of AM is twice the maximum frequency of the modulating signal. Okay, if we consider single frequency modulating signal as a single frequency, that is called single tone modulation. In that case, it will be equal to 2 times the modulating frequency, bandwidth equal to 2FM. Another important parameter of modulated signal is modulation index, or it is also called the depth of modulation. Depth of modulation. It's an important characteristics of a modulated signal, a modulated signal. As far as a modulated signal is concerned, it is defined as modulation index is the ratio of amplitude of the modulating signal to the amplitude of carrier wave. In this case, we are assuming modulating signal as a single frequency signal. It contains a single frequency. Okay, so that signal is having an amplitude, which is the peak value achieved by the modulating signal. Usually it is denoted as AM. AM is the amplitude of the modulating signal, and amplitude of the carrier wave is denoted as AC, that is the peak value of the carrier wave. Then the ratio of amplitude of modulating signal to amplitude of carrier wave is known as modulation index for a single frequency case. For example, if you consider modulating amplitude AM equal to say 7 volt, peak amplitude of the modulating signal is 7 volt, and carrier is having an amplitude peak value of 10 volt, then modulation index can be calculated using this formula, AM, that is 7 volt by 10 volt. Modulation index equal to 0.7. So modulation index does not have any unit. It is a ratio of voltages of two currents. The modulation index is an important characteristics of a modulated signal. So this is an important term as far as modulated signal is concerned. So in the case of AM, it is defined as the ratio of modulating signal to amplitude of carrier wave. Okay. Okay, right. Let us move on to next slide. Here, modulation index can be calculated in another form. It's a different form. Calculate this different formula for calculating modulation index. And modulation index as ratio of modulating amplitude by carrier amplitude, AM by AC. If you consider a modulated signal, this is a modulated wave, AM modulated wave, and the amplitude of the modulated signal varies instantaneously, like this. And the peak value is denoted as A max. So A max is the peak value of the modulated signal. AM, A max. A max indicate maximum value of the modulated signal. Maximum value of modulated signal. Modulated signal So A max from figure, it is clear that A max equal to, what is the value of A max? A max equal to this value, A max, okay, right, A max minus A minimum. Okay, right. We'll define another term also. A minimum is the minimum. This value is the minimum value of the modulated signal. A minimum is the minimum value of modulated signal. So if we know maximum value of the modulated signal and minimum value of modulated signal, modulation index can also be calculated using this formula. A max. A max minus A minimum divided by A max plus A minimum. So this is another formula for calculating modulation index of AM signal. So in this case, maximum amplitude, minimum amplitude are given. Maximum and the minimum amplitude of the modulated signal is given. In that case, modulation index can be calculated like this. If we consider this example with the maximum value, A max, maximum value of the modulated signal as 12, and the minimum value of the modulated signal, A minimum equal to 8 volt. Maximum value is 12 volt and minimum value equal to 8 volt. Then modulation index, how will you calculate modulation index? M. Using this formula, we can calculate M equal to, what is the value? Value of A max is 12. 12 minus 8 divided by 12 plus 8. 12 minus 8 is 4 divided by 20. 4 by 20 equal to 1 by 5 equal to 0.2. The modulation index equal to 0.2. Right? So I hope you understand this topic. Modulation index. So let us move on to next slide. Okay, thank you. Thank you. Next, yes. Power calculation. This is an important topic. Power calculation of AM. We already discussed about the spectrum of AM signal. So power consists of in all the spectral components. The AM signal contains unmodulated carrier plus lower sideband, LSB, and upper sideband, USB. So these are different frequency components present in AM signal. All these frequency components consist of power. The total power of AM, total power of AM denoted as PT equal to power of unmodulated carrier, which is denoted as PC, plus PUSB plus PLSB. This equation is given. PT equal to total power of AM equal to carrier power plus sideband power. There are two sidebands, upper and lower sidebands. Now, upper and lower sidebands are equal for AM. PUSB and PLSB, these two power terms are equal for general AM signal and is given by modulation index. We have denoted as modulation index as M. So please correct this equation using notation M. Okay. Sometimes mu will be used. I will correct this equation. Pt equal to Pc into 1 plus m square by 2. Sometimes mu is also used for denoting modulation index. So PUSB equal to PLSB, which is given by m square PC divided by 4. So this is the amount of sideband power, lower or upper sideband power. And total sideband power is PSB, total sideband power. Sideband power. So what is total sideband power? It is the sum of upper sideband power and lower sideband power. PUSB plus PLSB equal to total sideband power. We can substitute the value of LSB, power of LSB or power of USB using this formula m square by 4 PC. This is the power of one sideband, upper sideband plus power of lower sideband, which is also m square by 4 PC. Total sideband power become PC into m square by 4 plus m square by 4. It will be 2 times m square by 4, which is equal to m square by 2 PC. This is expression for sideband power. Okay. So power contained in a AM is PC plus total sideband power. So total power PC equal to PT equal to PC plus PSB, sideband power. PC plus sideband power is already obtained as m square by 2 into PC. If you take PC as a common term, PC into 1 plus m square by 2. This is an important expression because plenty of questions will be asked relating this equation. That is total power of AM equal to PC. It depends on carrier power and modulation index. So as modulation index varies from 0 to 1. So modulation index in the case of AM, that's an important term. Modulation index lies in the range 0 to unity. Maximum modulation index M as a percentage is 100%. You should note this. Maximum modulation index is 1 for AM. For AM, maximum value of modulation is 1 or 100%. Okay. If modulation index is more than 100%, that is AM greater than AC. If this is the situation, then that condition will produce noise. Okay. So noise will be produced. No, actually, there will be a phase inversion at the receiver side. Phase inversion at the receiver side will occur. So we can't exactly regenerate modulated signal at the receiver side. And that condition is called over modulation. So over modulation for condition, then modulation index is more than 1. That is AM greater than AC. So in that condition, there will be phase reversal at the receiver side. So exact signal will not be regenerated at the receiver side. The effect is called over modulation. Over modulation. So you should clearly note this condition of modulation index for AM signal. Modulation index is always in the range 0 to 1, or maximum modulation is 100%. So coming back into the discussion of power calculation of AM, PT, that is total power of AM, depends upon PC. PC is carrier power and also on modulation index. As modulation index increases, total power increases. Right? Okay. Any doubt in this topic? I think it is clear. You should clearly note this equation, PT equal to PC into 1 plus m square by 2. This is an important equation. Next topic is advantage and disadvantages of amplitude modulation. Amplitude modulation is a simple technique. So we require simple modulator and receiver. Modulator structure and receiver structure is simple. AM advantages are AM modulation is easier to implement because the structure used for or system used for AM modulation is simple in transmitter side and receiver side. Demodulation can be done using few components in a circuit. If you have a transistor and a filter circuit and a audio system, then we can demodulate AM signal. So it is a simple circuit. We need a diode detector and an amplifier, diode transistor and a filter circuit. Third point is receiver used for AM is very cheap. That is why AM is still used in radio communication because receiver is very cheap. So everybody can get one receiver and transmission. It is a broadcasting technique, AM broadcasting technique, so that maximum number of receivers are required. So in the case of AM, a receiver is very cheap. So number of AM receivers will be more. So for people can also accommodate AM receiver because it is very cheap. Demodulation can be done using few components. And first one, amplitude modulation is easier to implement. So these are 3 points. Advantages. Now coming to disadvantage. When it comes to power usage, it is not efficient. It is less efficient as far as power usage is concerned because lot more power is wasted, which does not carry information. Carrier power is transmitted along with the information power, sideband power, and carrier power does not hold any information. So it is actually wastage of power. Okay. So that is first point. When it comes to power usage, it is not efficient. Second point, it requires a very high bandwidth that is equivalent to that of highest audio frequency. We know that bandwidth of AM is twice the maximum frequency of audio signal. Therefore, larger bandwidth is required. We require larger bandwidth. If FM is large value, then bandwidth required will be twice that value, which will be more than actually required. Third point is noise interference is highly noticeable. Third point, the disadvantage is noise interference because information is carried in the amplitude of the modulated signal, and noise is most susceptible. Amplitude is most susceptible to noise. Noise will be easily added with the amplitude. So noise interference is highly noticeable. So in AM, we can't separate noise from actual information. So noise interference is highly noticeable in the case of AM. So these are disadvantages. Okay. And the important advantage is receiver used in AM is very cheap. That is why AM is still there. Next, we'll discuss few more modifications of AM system. There are several modifications for AM system. In AM system, unmodulated carrier along with the sidebands are transmitted, and the power in the carrier is a wastage of power. Okay, so we can save power by suppressing carrier. If carrier component is suppressed, we'll get another modulation scheme which is called a double sideband suppressed carrier. So DSBSC means double sideband suppressed carrier. So what is the meaning of suppressed carrier? Suppressed carrier means carrier power is suppressed. No carrier is transmitted. So in DSBSC system signal, only two frequency components will be present. They are the upper sideband and lower sideband. Okay. Carrier is not transmitted. Because of this reason, PT equal to PC into 1 plus m square by 2 is the formula for total power. This is equal to PC plus m square by 2 into PC. If we suppress carrier by suppressing carrier, okay, by suppressing this term, the power can be power of DSB reduced into this term m square by 2 into PC. Now PC component is suppressed, so we can save a large amount of power. Okay, if this carrier is suppressed and the saved power is distributed to sidebands, then such a process is called double sideband suppressor carrier. So in double sideband suppressor carrier system, we are using a modulator which suppress the carrier. Modulating signal, the block diagram of DSBSC modulating signal or message signal is applied to a DSBSC system. DSB, double sideband suppressed carrier system. Carrier is also applied. Carrier frequency FC. We consider FC as carrier frequency and modulating frequency as FM. DSBSC signal contains only two frequency components. First one is FC plus FM component. This is USB upper sideband, and FC minus FM component, LSB. So DSBSC signal contains two frequency components. Okay. So in DSBSC, we are just suppressing carrier in order to save power. Right? Okay. Next, bandwidth of DSBSC wave. If we consider bandwidth of DSBSC wave, we should get the maximum frequency and minimum frequency. The highest frequency, F max, present in DSBSC is the USB frequency, isn't it? USB. So what is USB frequency? FC plus FM. And minimum frequency in DSBSC equal to FC minus FM. Okay, this is maximum frequency, which is upper sideband frequency, FC plus FM, and F minimum is the lower sideband frequency, USB and LSB frequencies. Next, bandwidth. Bandwidth is defined as difference. Bandwidth equal to maximum frequency F max minus F minimum. We will obtain same expression as AM, standard AM, that is FC plus FM minus of FC minus FM. So taking the difference between these two frequencies, we'll get 2FM as bandwidth. So bandwidth of DSBSC signal is same as the bandwidth of AM, which is equal to 2FM. Now, what about power calculation? Power calculation, we have already done power calculation. Total power of AM power equal to PC into 1 plus m square by 2, which is equal to PC plus m squared by 2 PC. Therefore, by suppressing carrier, we'll get DSBSC power of DSBSC equal to m squared by 2, which is equal to USB plus PLSB, total sideband power, PSB. So power of DSBSC equal to sideband power, total sideband power, lower and upper sideband power. So this is expression for power of DSBSC. Please note down power of DSBSC and bandwidth of DSBSC signal. Hope all of you got the idea or expressions are clear. Next modification of AM. Next modification of AM is SSBSC. What is SSB? SSB stands for single sideband. Single sideband suppressed carrier system. Suppressed carrier. SSBSC, the modulation scheme, in which in this scheme we are suppressing one of the sideband and transmitting only one sideband or a single sideband. We can suppress either USB or LSB from a DSBSC signal to obtain SSB. Okay, there is no need of transmitting two sidebands. We can suppress a sideband to obtain a lesser bandwidth signal. So to obtain a bandwidth reduction, the process of suppressing one of the sideband along with the carrier and transmitting a single sideband is used. And this technique is called SSBSC. So in this, we'll suppress one of the sidebands along with the carrier. Okay, only one sideband is transmitted. So we can save both bandwidth and power in SSBSC. So all these three modulation schemes, AM, SSB, DSBSC, and SSBSC, SSBSC is having lowest power and lowest bandwidth. Bandwidth required for SSBSC is half the bandwidth of DSBSC or AM. So this is equal to half the bandwidth. Half the bandwidth required for either AM or DSBSC. Okay. So bandwidth is saved in this case. You can save bandwidth also in SSBSC. Now what about power calculation? Power of SSBSC, power of SSB signal is either PUSB or PLSB. Okay, we can write in bracket PUSB or PLSB. What are say? Now, what is the expression for PUSB? Is m squared by 4 PC. PSSB equal to m squared by 4 PC. Isn't it? Only one sideband is required. So total power of single sideband suppressed carrier system is m squared by 4, and which is half the power required for DSBSC. So SSB, using SSB, we can save power. Power can be saved, can save bandwidth also. But circuit complexity is more. Complexity is more. Okay. So the circuit of both the transmitter and the receiver circuit of SSBSC is more complex and high frequency highly frequency sensitive. The circuit is having high frequency sensitivity, which means that when the frequency of carrier frequency is varied, we can't obtain correct reception. The circuit is having high frequency sensitivity. So we have to use oscillators with the high frequency stability in the case of SSB-SC receiver. At the receiver side, we should use oscillators which is having high frequency sensitivity, frequency stability. So we have to use frequency stability. Frequency stability should be more for SSB-SC receiver. Okay, so this is a disadvantage of SSB-SC receiver. First point is circuit is complex. Circuit is having high frequency sensitivity. And third point is frequency stability should be more for SSB-SC receiver. Now we'll compare advantages of DSBSC or SSB or DSBSC and AM. First point is bandwidth or spectral space occupied by SSBSC is less than AM and DSBSC. So which is FM for SSB. For AM it is 2FM. For DSBSC it is 2FM. So bandwidth requirement for SSBSC is less compared with the AM and DSBSC wave. This is the first point, advantage of SSBSC. Advantages of SSBSC. Second point, transmission of more number of signals is allowed. Advantage, since bandwidth is less, we can transmit more number of signals through the same channel. Okay, so in this case, channel bandwidth is effectively used. This is because the bandwidth of SSBSC is less comparing with the AM and the DSBSC. Therefore, we can transmit more number of signals through a given channel. That means channel bandwidth is effectively used. Third point is power is saved. You can save power. Power used for transmission of SSBSC is very small comparing with that of AM and DSBSC. Next point is less amount of noise is present. Since bandwidth is less, noise will also be less. Signal fading is less likely to occur. Signal fading is variation in signal amplitude as a function of frequency. For different frequency, signal will be received at different times with a different amplitude. Signal fading is less likely to occur because it is having less bandwidth comparing with the other two systems. Signal fading is less likely to occur. So these are advantages. Okay, clear? The most important advantage. Okay, I repeat fading. Okay, right. Okay, I will repeat it. Signal fading is, if we consider a range of frequency, at the receiver side, a particular frequency, say 200 megahertz. This signal and strength will be varied at different times. So there will be a frequency concept, a particular frequency component will be received at different strengths at a different time. Okay, so when we listen a radio station which is having signal fading, the amplitude, volume of the noise, volume of the audio will swing. Okay, will swing, will vary. Okay, from time to time. So there will be volume modification. Okay, that is due to fading. Actually, fading occurs due to nonlinear behavior of the transmitting medium. There will be several. There are several type of fading, fast fading and slow fading, etc. But fading means there is a variation in amplitude of a particular frequency at a different time in the receiver side. Okay, when you listen some distant radio stations, there will be fading. Okay, did you notice that fading? It will be like voice modification in time. Is it clear? And this is due to impairments in the communication channel, that is the medium through which it is transmitted, because of multiple reflections from different reflecting surfaces due to moving objects in the atmosphere, etc. And this is also due to change in properties of atmosphere. So fading is the variation in amplitude at a particular frequency from time to time at the receiver side. So it is related to frequency as well as time. Clear? I think it is clear. Oh, thank you. Thank you. Thank you, sir. All right. Next, disadvantages. The generation and detection of SSB-SC wave is complex process. First disadvantage is generation and detection of SSB-SC wave is a complex process. We have already discussed about this. Second thing is quality of the signal get affected unless SSB transmitter and receiver have an excellent frequency stability. Frequency stability is an important requirement in the case of SSB transmitter and receiver. There should be frequency stability at the transmitting side and receiver side, because there is no carrier that is transmitted along with the message signal, modulated signal. There is no carrier wave. So in order to obtain the coherence of the carrier wave, we should have excellent frequency stability. If frequency changes with the temperature from time to time, the system will fail. The quality of signal get affected unless SSB transmitter and receiver have an excellent frequency stability. So these are disadvantages of SSB system. Applications of SSB. As we already discussed, there is a saving of power and bandwidth requirement. So SSB is used in most of the communication applications for power saving. How frequency stability is affected. Yes, since we are transmitting a single sideband, that is FC plus FM, okay, FC plus FM or FC minus FM. If we are transmitting USB, which is FC plus FM, and LSB, which is FC minus FM, any shift in this frequency will cause shift in the demodulated signal. Okay, a shift in this frequency, FC plus FM is maybe due to shift in carrier frequency, but it will affect the modulating signal frequency also. So the receiver side, there will be frequency distortion. And this frequency distortion is not acceptable as compared with the amplitude distortion. frequency distortion will be highly affected in communication system when comparing with the more amplitude distortions. Okay. So distortion, there will be shift in frequency of the demodulated signal at the receiver. Since the receiver is also tuned to the same frequency, FC plus FM, any deviation of the frequency from the transmitter side will affect the received modulating signal frequency. Is it clear? If there is a change in this transmitted frequency due to discrepancies in FC or FC, that will affect the frequency of demodulated signal. The demodulator can't understand actual frequency and the deviation. It will demodulate accordingly, and there will be a shift in modulating signal frequency. Okay, right. Thank you. So that is why excellent frequency stability is required. And finally, we are discussing about applications of SSB for power saving requirement and a low bandwidth requirement. It is used in power saving. So there are advantages of saving power and bandwidth as far as SSPSC is concerned. So it is used for power saving requirement and low bandwidth requirement. So it is used in land, air, and maritime. Three different applications of mobile communication are land, air, and maritime mobile communication, because it is using mobile communication is essentially require less power. Okay, because the mobile stations are should not carry the power source at all time. So the power requirement in mobile communication must be less comparing with the fixed communication. So it is used. This SSP technique is used in mobile communication, land, air, and maritime mobile communication. It is used in point-to-point communication also. In radio communication, transmitting audio information through radio communication, television, telemetry, long distance measurement is telemetry, radar communication, radio detection and ranging. It's a communication system used in military. Next, military communication such as amateur radio, etc. So these are a few applications. Amateur radio is also using this SSB technique, single sideband modulation technique, because of less bandwidth and power saving capability of SSB. So these are applications of SSB. With this, we are at the end of the discussion of theory. Then we will move on to questions asked in this section. These questions are taken from previous list papers. So all these questions are previously asked questions. So try to do all these questions. Some numerical questions are also there. Hope you understand all the concept that we have already discussed. If any doubt, you can ask now. A lot of questions are asked from this topic. What AM, DSPSC, and power bandwidth calculations. So let us move on to question section. First question. In AM, carrier is changed by a modulating signal. What is parameter of carrier? What parameter of carrier is changed? You can type correct answer and send. Amplitude, right? Yes, amplitude, right answer. Yes, all of you got the right answer. Emya, Chetan, all of you got right answer. Amplitude of the carrier is varied. Okay, it's a simple question. In AM, carrier amplitude is varied. This is AM. What about second one? Frequency is varied. Then that is FM, isn't it? FM system. Pulse width, and this we're going to discuss It is PWM. PWM is pulse width modulation that we will discuss in detail. And fourth option is phase. We'll get the PM system. Okay. So different modulation schemes use different characteristics of the carrier wave to change accordance with the modulating signal. So these amplitude, frequency, and phase modulation are carrier modulation schemes, and the pulse width modulation is pulse modulation scheme. So this is a pulse modulation scheme. This is also analog modulation, but carrier, sinusoidal carrier is not used. Instead of that, a pulse having fixed amplitude and duration is used in PWM. Next question. In AM transmission, the frequency which is not transmitted. In AM transmission, when we transmit AM signal, the frequency which is not transmitted is, yes, option D, right. Yes, Sudhap, Gayatri, Chetan. So all of you got a right answer, audio frequency. See, the other options, upper sideband USB is a part of AM, LSB is a part of AM, carrier frequency is a part of AM. So only frequency component which is not transmitted is audio frequency. So correct answer is option D. Okay. So this is also a direct question. Third question. Sorry. The output spectrum of a dash modulator includes upper sideband and lower sideband frequency and carrier frequency. Which one? Yes, standard AM. This is normal AM or general AM signal. Standard AM or simply amplitude modulation. Okay, right answer is B. I think it is obvious for all of you. Next question. Double sideband DSB and a single sideband SSB are type of which modulation schemes? DSB, double sideband, and yes, Rangarajan, option A, analog modulation schemes. Yes, that is right. What are other options? Digital modulation. No, it is not digital modulation, analog transmission. Actually, it is modulation scheme. So right answer is analog modulation. I think question is clear. Double sideband and a single sideband. DSB and SSB are types of which modulation schemes? Analog modulation schemes. They are different forms of AM. One practical question is FM radio station like Radio Mirchi, FM Rainbow, Big FM, etc. radiating in FM band. Users are able to listen to these stations by tuning their sets to different frequencies. Such type of system is known as. See, they are transmitting in FM band. Okay, FM band. Okay, why different people can listen these stations, even if they are transmitting in the same band? Yes, FDM is correct answer. Frequency division multiplexing. They are using different carrier frequencies for transmission. So different stations are using different frequencies, and their station is tuned for that particular frequency. Carrier frequency will be different. So this is achieved by frequency division multiplexing, FDM. What are other options? Radio Mirchi transmission. Now, phase shift keying. This is a modulation scheme called digital modulation scheme. TDM is another technique of multiplexing, but in this case, FDM is correct answer. Okay, clear? Next, which system is free from noise? FM, AM, both FM and AM, none of this. FM, FM. FM system is less noisy than AM, but yes, Radil, rather is correct. Rather is correct. Agil, yes, correct. None of these systems are independent of noise. All systems will have noise. All analog communication system, analog or digital communication system will have noise. Noise cannot be completely suppressed or separated. And there, as compared with AM, FM is having less noise. That's all. So, which system is free from noise? None of these are free from noise. Neither FM nor AM is free from noise. So, correct option is none of these. Hope you understood. When comparing with AM, FM is less noisy. Yes, thank you. Next question is a numerical question. Sorry. A carrier wave of frequency 10 megahertz, a carrier frequency of 10 megahertz and peak value 10 volt is amplitude modulated by a 5 kilohertz sine wave of amplitude 6 volt. The modulation index is. Calculate. Yes. Yes. All of you got say answer option C. Sorry. Yes. Option C is correct. Option C is correct. Modulation index. Index is calculated. M is equal to AM divided by AC. What is AM? Amplitude of modulating signal. Amplitude of modulating signal, AM equal to 6 volt. This AM, and amplitude of the carrier wave is 10 volt. AC equal to 10 volt. Okay, so all of you can simply calculate by taking this ratio. 6 volt by 10 volt equal to 0.6. The modulation index is AM by AC, which is equal to 6 by 10.6 is the right answer. Okay, so it's a simple calculation. Sorry. Next question. Amplitude modulation is a dash process. A, modulation. Options are multiplication, B, division, C, sum or difference. Yes. Right answer. Yes. Not sum or difference. Actually, it is multiplication. Actually, it is multiplication. Modulating signal and carrier is multiplied. Actually, modulating signal. There is some doubt. So I will explain this. Modulating signal, that is denote this as M of t carrier, C of t as denote carrier as C of t, AM. This is a multiplier. Okay, multiplier. We will produce a DSBSC signal. DSBSC signal. This is product of M of t plus C of t. Okay. So basically, a modulator consists of a multiplier. Okay. Multiplication of carrier and a modulating signal will produce a modulation. If we add the carrier signal along with the DSPSC signal, we'll get a. So basically, multiplication is the process of modulation, AM modulation. Correct answer is multiplication. Okay. So this will be AM. Next question. An important question. The modulation index of an AM is changed from 0 to 1. How does transmitted power change? How does transmitted power change? Option C, right. Rupa, Sridevi, right. Suraj, correct answer. Yes. So you need some clarification. Option C is correct. I will obtain that answer. Total power, power of AM equal to PC into 1 plus m square by 2. When modulating signal is 0, modulating amplitude is 0, modulating amplitude equal to AM equal to 0, then modulation index M, which is equal to AM by AC, this also becomes 0. When modulating signal amplitude becomes 0, power transmitted in AM is the lowest value, which is equal to PC into, when we substitute M equal to 0 in this expression, we'll get AM is equal to PC, the minimum value. Minimum value. So when M equal to 0, this will happen when M equal to 0. When M equal to 1, AM power of AM become PC into 1 plus 1 square by 2 when M equal to, this is when M equal to 1, and that is equal to 3 by 2 PC. So PC is increased to 3 by 2 PC. Okay, so change, this is minimum and this is maximum. Change in power, change in power divided by carrier power PC into 100 will give percentage value. Change in power is 3 by 2 PC minus PC, which is equal to 3 divided by 2 PC minus PC divided by PC into 100. So this will give 50%. 3 by 2 minus PC, 3 by 2 PC minus PC is 1 by 2 PC, and it will be 50%. So correct answer is 50%. There will be an increase of 50% power. Power increases from PC to 3 by 2 PC. Right answer is option C. Okay. Let us move on to next question. An amplitude modulated system, if total power is 600 watt and power in carrier is 400 watt, then the modulation index is the value of modulation index M. Total power of AM is 600 watt and carrier power is 400 watt. This is also an important question. One, yes, Hari Krishna. Right answer. Answer D. Right. Okay, how do you calculate this? Yes, Ramya. Right answer. Here, total power of AM is given as PAM equal to 600 watts, and carrier power is also given, PC equal to 400 watt. You can use this formula, PAM equal to PC into 1 plus M squared by 2. Have to calculate M. Substituting, we'll get 1 plus M square. Yes, Rupa. Right answer. Option D is correct. So all of you try to do the question. It's very simple. PAM equal to 600, PC equal to 400, PC into 1 plus m squared by 2. This term 1 plus m squared by 2 equal to 600 by 400, that is equal to 1.5. 600 by 400, we get 1.5. From that, we'll obtain m squared by 2 equal to 0.5. So m squared equal to 1 or m equal to 1. Modulation index equal to 1. The right answer is option D. Okay. Next question. If a 1 megahertz carrier is amplitude modulated with a 5 kilohertz audio signal, the upper side frequency is dash kilohertz. Upper side frequency is Rupa. Right. Okay. So all of you got correct answer. 1 megahertz plus 5 kilo. 1 megahertz plus in kilohertz. 1 megahertz is carrier frequency. Yes. FC is given. FM equal to, it is given in 5 kilohertz. Only thing is that you have to convert megahertz into kilohertz. What is the value of 1 megahertz in kilohertz? 1 megahertz is 10 raised to 6 hertz. That is equal to 1000 kilohertz. Right? 1000 kilohertz. So upper side frequency FUSB equal to FC plus FM. FC plus FM, which is equal to 1000 plus 5. 1005. So all these questions are very simple, even if they are numerical questions. If you know the expression or equation of the quantities related, then you can do very simply. Only a few calculations are required. So correct answer in this case is 1005 kilohertz. Next question. This is also an important question repeatedly asked in many question papers. A 10 kilohertz carrier is simultaneously modulated by two carriers corresponding to a modulation index of 30%, 30% and 40% respectively. So different carriers are used. They are modulated individually by 30% and 40% respectively. The total power radiated. We have to find the total power radiated. Okay. Right. Here, there are two modulation indexes that are given. For first one, Saujit got 12.5 kilohertz. Okay. We can check the answer. I will give a brief theory related to this. M1 equal to 30%. 30% means M1 equal to 0.3. Modulation index of first wave is 0.3. Modulation index of second wave equal to, yes, you got 11.25. So, Hari Krishnan 11.25. So there is a confusion regarding the correct answer. M2 equal to, okay, 12.5. Rangarajan. M2 equal to 40%, which means M2 as a fraction, it is 0.4. If there are several sinusoidal waves, they are separately modulated like this. Total modulation index can be calculated. Total modulation index is a formula. Modulation index or resultant modulation index is given by square root of m1 square plus m2 square. Now we can calculate resultant modulation index using this formula, 0.3 square plus 0.4 square, and this is 0.5. Can calculate this. It will be 0.5. Yes, Saurabh. Yes, Saurabh. Got option A. Let me check the answer. Total modulation index m equal to 0.5. The total power of AM. Total power of AM equal to PC into 1 plus m squared by 2. PC is given as PC equal to 10 kilowatt. 10 into 1 plus 0.5 squared by 2. Substituting m equal to 0.5 and PC equal to 10 kilowatt, we'll get this answer. What is 0.5 square divided by 2? It is 0.25 divided by 2, 0.125. So 10 into 1.125 equal to 11.25 is the right answer. 11.25 is the right answer. So in this case, first we have calculated the resultant modulation index M using this formula. This is an important formula. If different waveforms modulate separately with the modulation indices M1, M1 and M2, the overall modulation index is given by square root of M1 square plus M2 square. After calculating resultant modulation index, you can use the formula for total power of AM to calculate the total power of AM as 11.25 kilowatt. Right answer is option A. Okay. Right. Next question. The carrier voltage of unmodulated carrier power 1 kilowatt on being amplitude modulated by an audio signal voltage to a depth of 100% as total modulated carrier power of. We have carrier power 1 kilowatt. Yes, Chetna, 0.5 kilowatt. 1 kilowatt is the carrier power. Yes, you have to calculate sideband power also, Hari Krishnan. All of you got 1.5 kilowatt, right? So here PC is given. Yes, option B, right. Here PC is given as 1 kilowatt. Yes, Saurabh. Option B is right answer. Modulation index equal to 100% or M equal to 1. The total power of modulated signal, AM power, PAM equal to PC into 1 plus M squared by 2. PC is 1 kilowatt into 1 plus 1 squared by 2, which is equal to 0.5, 1 plus 0.1, 0.5. So how much is the sideband power? Total sideband power is 0.5 watt. If we are asked to calculate sideband power, total sideband power PSB equal to 0.5 watt. This is sideband power. Okay. Okay. 0.5, and lower and upper sideband power LSB equal to PUSB will be half of this value, 0.25 watt. Okay, right answer is 1.5 kilowatt. Option B is correct. That's all for today. Remaining topics in analog communication will be discussed in next class. Topics like FM and PM will be discussed in the next class. If you have any doubt in this topic, you can ask it now. What about problems, numerical questions? Those few numerical questions will be asked in this topic. These are typically asked questions. All of you go through these topics, and you can see in the next class. Thank you all. Thank you, all of you.